Hello, everyone. How are you? Thank you very much for coming to this signal last night. I'm very sorry I'm not there with you guys, but I have some cold symptoms, so I cannot go. I'm feeling okay, but it's best to be safe than sorry, and I don't think I'm allowed to go anyway. Okay, so first thing first, happy Star Wars Day. May the 4th be with you. Sorry, just 1 second. I need to get something. Okay. I would like to thank our sponsors, Craig from Imperva, Ricky from Talenza, and developer Steve from the Stick for their continued support for helping us in setting up today's event. Now, before I pass on to Cherry to introduce our great speaker today, who is going to teach us something magnificent, I would like to invite all of us to congratulate Jack, young fella sitting at the desk, for graduating with first class honors in computer science from the University of New South Wales. So, well done, Jack. All right, with these happy tones, let's pass it to Cherry to introduce today's presentation.
Hey everyone. So what you've all been looking forward to, let me introduce you to Thomas. Thomas is located in Melbourne and he's a senior security researcher at Microsoft. And he's here today to talk about malware evasion techniques and how we can bolster our security against that. So I'll pass on to Thomas now to begin his presentation.
Awesome. Thank you, Cherry. Let me share my screen. Okay, can you see my screen? I guess yes. Okay, can you see my screen, guys? I don't have any sound, so perfect.
Yeah, we can see it.
All right, okay, I can't hear you now. Perfect. Thank you very much. Let me just put it in full screen. That's perfect. All right. Thank you very much for the introduction and for giving me the opportunity to present this project at the OWASP Sydney chapter. I hope next time I will be on site discussing with all of you. I'm really eager to discover the local community and see the great people there is there. So in this presentation, I will talk about the Unprotect project, which is actually a malware evasion techniques database. So I will discuss that a bit more in detail in this presentation, but mostly the goal is to provide knowledge and information about evasion techniques used by malware. So my name is Thomas Rocha. I'm a security researcher at Microsoft. I used to work from France and I've been relocated to Melbourne, Australia 3 months ago, joining the Microsoft Defender team in Melbourne. And my work is mainly focused on tracking new threats, improving the technology, improving as well the detections, and working on new techniques that can be uncovered. Before joining Microsoft, I worked for the past 6 years at McAfee in the advanced threat research team, where I was mainly focused on threat intelligence, tracking threat actors, cybercrime, and collaborating as well with law enforcement. You can follow me on Twitter with my handle Frogger with a 0 instead of a O. And if you want to see some of my work, you can visit also my website where I share some of the stuff I'm working on. All right. So in this presentation, I will start by introduce you and define exactly what is evasion techniques. Then we will see some practical examples on famous malware that we can find in the wild. And then I will introduce the Unprotect project, and I will conclude to some update and some takeaway about this presentation. So before to introduce the Unprotect project, I think it's important to define what is exactly evasion techniques. And in 2017, I've been presenting this project at Beside Tel Aviv. Actually, it was a side project, but it was related to evasion techniques. And with a friend of mine, we decided to define the evasion techniques as the following. All the techniques used by a software to avoid static, dynamic, automatic, and human analysis in order to understand the behavior of the software. So it's really important to get that information in mind, because evasion techniques can also be used by legit software to avoid cracking, or for example, to avoid copywriting or reverse engineering and all that techniques. And from a malware perspective, we can define evasion techniques as all the techniques used by a malware to avoid and evade security solutions, security configuration, as well as human detection to perform malicious action the longer on the infected machine. And if we want to have an analogy, we can have this GIF, which is the Agent Jones in Matrix, in the Matrix. And imagine Agent Jones is a malware and is trying to avoid all the bullets, and every bullet represents a kind of techniques to analyze the malware or to detect it. And the goal of the evasion techniques is basically to avoid all the bullets. So why malware evasion techniques is important? First of all, when you think about evasion techniques, when you analyze malware, uh, probably in 90%, probably 95%, you can find at least one evasion techniques in the malware you will analyze. And that's why as well, in the MITRE attack matrix, I'm not sure if you're familiar with the MITRE attack, but basically it's a matrix that reference some tactical and techniques used by malware, and the goal is to profile different threat actors tradecraft. And in the MITRE attack matrix, there is a tactics column, which is defense evasion, which is actually the most dominant tactic, which is referenced in the matrix. So this is really important to understand that, especially because the defense evasion is not complete, and it's because it's very difficult to keep a track of all the evasion techniques used by a malware. So that's why the Unprotect project, the goal of the Unprotect project is actually to expand the defense evasion section, which is part of the MITRE attack matrix. And I've been collaborating with them on the MITRE attack, but also on MBC project, which is the malware behavior catalog. You can find some information on GitHub. And the Unprotect project and the MBC project have been collaborating together to improve the detection and the knowledge about the evasion techniques. Then there is also multiple categories that exist in the evasion techniques. If we want to quote some of them, we can have anti-sandboxing or anti-debugging, but we can also have anti-disassembling or anti-monitoring, for example. And it's also very important to understand that, because malware developers are using evasion techniques, but they are also making money with evasion techniques by selling packers or crypters. And in fact, if you are doing like a small research on Google with the keyword crypters, you will get a lot of different tools that are available with some price. This one is an example, Aspire Crypt, which is actually a packers which is specialized in injection. So the goal of these packers is basically to use the malware and to add another layer that will be used to inject the malware in a legitimate process. And it has also other features. So that's the executable, the main program actually. And here you can see that you can choose the target process where your malware will be injected, and it provides like a ready to go tools to malware developers to add some evasion techniques directly in the malware. Another example, which is available, Bitcrypter is available on an underground marketplace. I think this description came from Alphabay, and you can see that the price is relatively low. And this one is specialized for Windows 32-bit programs and .NET application as well. And once you have the executable, you can see some of the feature it has. So for example, you can add some anti-environment techniques, such as, for example, detecting the registry key against virtual machine environments, so like a VMware keys, for example. It can also disable the UAC or disable as well the task manager to avoid to kill the process, and so on. Another one which is very interesting is Edgecrypt. Edgecrypt is a crypto as a service, and originally Edgecrypt was known to collaborating with the Conti ransomware group, which is one of the biggest one of the biggest ransomware gang for the past years. And Conti was collaborating with Edgecrypt to pack their ransomware before to deploy it in infected machines and targeted environment. So this one is also very interesting because you can see that there is a whole business model around evasion techniques. So I already discussed some important concept about why malware author will use evasion techniques, but it's also important to actually we can distinguish three different categories. The first one is anti-security techniques. So in that part, we will have all the techniques that are used to avoid detection by security solutions such as antiviruses, firewall, application containment, and other tools. The second one is anti-sandboxing techniques, which are all the techniques used to detect automatic analysis, meaning automatic sandboxing, such as, for example, Cuckoo, app.any.run, which is also an online sandbox. And all that automatic sandbox will be detected by this kind of techniques. And the last one is anti-analysis techniques, which are basically all the techniques used by a malware to avoid reverse engineering, monitoring. For example, it can use some techniques that will try to spot monitoring tools such as Process Explorer, Wireshark, or Process Monitor, for example. And in that different techniques, if the malware will detect, for example, if we take the anti-analysis technique, if it detects the Wireshark process running, the malware can simply decide to not run on the machine, or to act differently, or or even to destroy the machine. That's the case also, or it's possible that the malware will act differently. And then if you want to analyze it, um, you will have to bypass all the anti-techniques method used in the malware to be able to reverse engineering it and to understand what it does. So now let's talk about some practical evasion techniques that we can find in the wild. So when we talk about evasion techniques, it's really interesting because we can find evasion techniques actually at every sequence of an attack. So for example, we can have some evasion techniques during the infection vector phase, during the delivery phase. So if we take an example, if we take as an example a malicious document with an embedded macro, the macro can come obfuscated. It can have additional features that will detect, for example, the network. It can check if the network is currently the right one to infect, or it can also make some geolocalization network detection. And if the sample is running in, for example, in Australia, it will not run properly. But if it's running in the US, it will run correctly. Then the second phase of the attack will be the malware delivery. So once once the malicious attachment have been delivered into the machine, the second stage will be to deliver a malware, and most of the time it can be an executable which will come packed with some additional layers. It can also have some anti-debugging techniques to avoid dynamic reverse engineering. And it can also have some obfuscation with like data obfuscation, variable obfuscation as well, and so on. Um, Once the malware is finally unpacked into the machine and running into the machine, we talk about the malware behavior. And at that sequence, actually, we can also have some additional evasion techniques, such as sandbox evasion, detecting the registry key related to VMware environment or VirtualBox or QEMU, for example. It can also have some code injection mechanism, such as, for example, process hollowing, which is a known process injection. And it can also have some feature to bypass the anti-malware on the machine. For example, it can be like disable the services running related to Defender, if we take the Defender as an example, but it can be another antivirus, and so on. And then we have also the action on objective, where we can find as well some evasion techniques related to the network. So for example, the malware can use DGA, domain generation algorithm, or fast flux, which are known network evasions, just to communicate with the command and control and to bypass firewall in place and security in place. They can also have some encryption to communicate with the command and control server. And that way, if you are listening the network but not checking the encrypted packet, you will not see anything malicious. And the last one is Tor network. Most of the ransomware actors are using Tor for interacting with the victim, but it can also be used for command and control server as well. So let's talk now about a real example, Emotet, which is a famous malware. In that example, during the delivery phase, so this Emotet variant was coming in a malicious document, and the malicious document was using an obfuscated macro, as you can see here. This obfuscated macro was running a PowerShell command in base64 encoded, which was also obfuscated, as you can see here, and it's not very clear, but there is some check about the processes running on the machine before to download the Emotet executable into the machine. Once you get the executable, there is also additional evasion techniques. Here we talk about fake metadata. So the sample is currently this variant is currently binding with legit software to increase the amount of strings. And these techniques can be used to bypass machine learning detection and classification. So there is a lot of legit strings into the sample. And there is also like a fake icon and some fake metadata that have been used by this sample that can trick the user that will run the executable on the machine. So once you decided to reverse engineering this sample, you can see that there is also some anti-disassembling mechanism. So here it's a screenshot about the control flow graph, where we can see some code spaghetti, which are actually opaque predicate with fake operation to avoid the reverse engineering, to harden the reverse engineering. And it's more difficult to analyze that kind of programs. It takes more time actually, because you have to understand what is really useful in your analysis, what kind of function is really part of the Emotet variant, and what kind of function are just garbage and just here to disturb the analysis. And during the execution of this sample, there is also some additional evasion techniques related to the network. In that case, the samples is using some connection to some remote IP. So all the IP wasn't available into the binary because they were mostly obfuscated. But once you run the samples, you can see that there is several traffic to that IP which are actually related to different command and control used by this Emotet variant. And this is also another network evasion techniques. The sample is using not all this IP, but it was using actually it was checking which IP address was up to communicate with the one that answer directly to the sample. So if you get like a partial list of this IP, you won't be able to block the full Emotet variant because they will have additional IP address that won't be listed in your blacklist and your protections. So that's really important to understand all that concept to be able to have the best protection in your environment. So now that we know a bit more about evasion techniques, let me introduce you the Unprotect project. So I created this project in 2015. At that time, I was working as an incident responder, and I was working on several outbreaks at customer site. And many of the customers I've met at that time didn't realize that some of the malware were able to bypass the security in place using evasion techniques. So I started to document some of the evasion techniques, the most common, at least for bypassing sandboxing and bypassing antivirus, just to sensibilize, to teach the customers about that kind of evasion techniques and help them to understand why, in some cases, malware are able to bypass the security in place. In 2016, I did the first public presentation at the BotConf conference, which is a law enforcement conference in France dedicated to botnet fighting. In 2017, I created a proof of concept, which was actually creating some fake artifact related to VM in a regular machine. And that way, every malware that will check the different artifacts related to VMware or VirtualBox, for example, will not run on the regular machine. So it's actually just a small proof of concept that will create artifact into the machine related to VMs. And I also created the cheat sheets, which is related to sandbox hardening and best practices. In 2019, I did a presentation at Black Hat Asia Arsenal, where I released an open source tool, which is a Python tool actually dedicated to evasion techniques. So you basically run the executable, the Python script against an executable, and it will provide you a report about the evasion techniques used by the sample you want to analyze. You can find most of the code on my GitHub. Unfortunately, it's not updated. I'm sorry about that, but there is a new version in the pipe, and this new version should be implemented in the World project later this year, I hope. In 2020, we worked on the redesign of the website because originally it was a simple wiki with some documentation. And in 2020, we created like a new website and we added some code snippet, Yara, Sigma, and Kappa rules as well. And in 2021, we created the API for requesting the website and getting some information about the evasion techniques and so on. I will present that in the next slide. And in 2022, it depends of my time because it's an open source project. So I'm working on my side on it. It takes a lot of times, but it's open to the community, so everyone can participate as well. What's the goal exactly of this project is mainly to increase the knowledge and understanding of evasion techniques for threat analysts and reversers. It helps as well to document evasion techniques because there is plenty of different evasion techniques, and it can be very powerful to understand or to have like a full classification. The goal also is to extend the MITRE attack testing for if you are working like in the security industry. For example, there is some practice once per year where actually the MITRE is running different kind of testing against some security products. It can also be used to test your security in place with some red teaming exercise. It can also be used for hardening your malware analysis environment and so on. So I will jump on the next slide to show you like an overview of the first classification we had. So basically, this is a table where we classify the different techniques in different categories. So we have anti-sandboxing, antivirus evasion, anti-debugging, process manipulating, and so on until anti-machine learning techniques. And there is like a techniques for each of the different categories. So let me show you now the Unprotect project. Okay, I think you can see my screen. Okay, perfect. So the Unprotect project, uh, let me, okay, perfect. So the Unprotect project is currently a database where there is like a simple search engine, and you can make some research. For example, if you want to get some information about processor ping, which is a process injection techniques, you can click on it. You will have the result, and you will have more details about these techniques. So there is like a description, and there is for some of the techniques there is a code snippet you can actually reuse the code snippet and use the techniques by yourself. And for some other techniques, you will have Kappa rules, Yara rules, and Sigma rules, and you will also have additional resources, so external link related to the techniques. If you want to have like a full overview, you can go to map here, and you will have the different categories where we have anti-debugging, anti-disassembling, and so on. If you click on one of them, you will have the different list with the technique ID. So here is all the technique used to be used against debugging techniques and debugging reverse engineering and so on. And so there is all the techniques, and you can click on some of them to get the information. Let me show you the kill process, for example. This one. So same here, you will have the description for each. You will have the code snippet. So here we have two different code snippets. So that's interesting because sometimes there is multiple way to do the evasion techniques. Sometimes you can also have some Python code, Golang codes, PowerShell codes. It depends what the author decided to publish. So in that case, we have this author that published this one, and this one was from me. And you will have also the detection rules with the Kappa rules. So Kappa is a FireEye tool used to have some quick analysis about an executable. You can also have Sigma, which is used to hunt for logs, and you can also have the Yara rules for the specific techniques. So um, as I said, it's an open source project which is community centric. It's not complete because it requires a lot of times and a lot of people. And even if there is some people that sometimes participate to the project, it takes a lot of time to complete the whole database. So it's still a work in progress. If you want to contribute, you can have the Python page, the GitHub page where you have all the information about how to contribute. And if you want more information about the project, you can go to the About page where you get more information. You will see as well the maintainer and the different contributors. So if you want to participate, you will be listed at the lovely contributors in the list. Up. Where is my screen? All right. Sorry about that. Here we go. So Now that I presented database, I wanted to introduce you the Unprotect API, which is available on the website. So there is currently no limit, no request limit. So basically, you can actually at the moment I'm working on a Python wrapper for that. But basically, if you want to already request the API, you can just simply do it with Python using the request library and requesting that URL. Then you will get some information about the different links that you can request. So we have the categories, the the snippets and snippet here, and the different techniques. So that's a simple example to get the list of the different categories that are listed in the database. So you will have the different categories here using simply request and parsing for the categories in the JSON data that you will receive. Then you can also filter to get the whole list of the techniques. So here it's truncated because we cannot print in the presentation everything, but you have basically the examples to request all the techniques in the database. Here it's another examples to request some techniques related to anti-debugging. So you will have the list of the different techniques. Here as well, it's truncated. So it's a basic example, and I will share the presentation. I will share the slide after the presentation, so you will be able to reuse the code if you like. So that's another example to get a specific technique. So here we get the kill process as an example, and we have like the technique name and the description from the API. And we have also the Yara rules, which is here. So that's very interesting. This feature is very interesting to be able to request with the API because you can automate pretty much everything and get the Yara rules from the API and running in your own labs. So that's here an example where we have the Yara rules, which is used against a specific samples. So this one was specifically coded to kill some process, and we run the Yara scan against the file, and we have the detection which is available from our Yara rules previously get from the API. So that's a basic example of how to use the API and what kind of information you can have. As I said, there is the GitHub page where you can make your pull request if you want to modify the techniques, update the techniques, add a new technique as well. That would be awesome if you want to participate. So this project is really dedicated to the community. I think in the next version of the website, we will probably incorporate a link into the website to have something more easy for the people to contribute rather than using GitHub and making like a pull request and so on. So it's still in a work in progress. So before to jump to the question and answer, I wanted to give you a brief takeaway about this presentation. So here we discuss about some evasion techniques and why it's really important to understand the different techniques and why it's also important to have like a full classification which is dedicated to that kind of techniques, especially because evasion techniques are dominant in the threat landscape. In probably most of the sample you will analyze in your career, you will be in front of some evasion techniques at some point. Also, it's really important because evasion techniques allow to bypass security in place and the analysis, and it can save you sometimes to understand that kind of techniques when you are dealing with a very obfuscated samples with a lot of different mechanisms. As we saw, Emotet is using evasion techniques, but there is also trickbots, ransomware actors, and many other crimewares family are using evasion techniques. The goal of the Unprotect project is basically to propose the most possible complete documentation about evasion techniques. And of course, as this project is dedicated to the community, feel free to contribute. That would be awesome. I think that's a great project as well if you want to learn more about evasion techniques, and it will help a lot of people. Additional resources if you want to learn more about it. So there is a website on search.unprotect.it. You can also visit my Medium blog about the Unprotect project where I discussed about it. You have also the Unprotect tools, Python tools on my GitHub. And if you want to have a look to the Black Hat presentation, the link is here. And thank you very much. Really appreciate your time. Really appreciate the invitation. I hope you enjoyed this presentation and you learned something today. And if you have any questions, just feel free to ask. Thank you.
Sorry, I'm muted.
Cool.
So I was
No
gonna
worries.
say that was a great presentation. Thanks, Thomas. That was extremely educational. It's like, yeah, great project. Yeah, fantastic.
Thanks.
I have a couple of questions, but before I take the floor, like I usually do, let's see if anyone in either Discord or YouTube or in person have any questions. So please ask away.
Yeah, try it, and hopefully they can hear it. If not, I'll repeat it.
Awesome.
Okay.
Sid, I know the project is still quite young, but I'm just wondering, when it comes to the main techniques that you've worked with that are on the project, how much have you dealt with, say, Mac-related and Linux-related malware evasion techniques compared to Windows?
I'm not sure to hear well the question. Can you repeat, please?
Yeah.
Sure. So just in terms of the project, have you done a lot of analysis on Mac-related and Linux-related malware evasion techniques, or is it mostly Windows for now?
Right. So the question is related to evasion techniques used with macOS and for example and also Linux, I guess. So the question is for now the project is only dedicated to Windows, Windows executable and Windows environment, but with time, ideally the goal will be to extend the project to macOS and Linux as well, because you are totally right. This is also a point of interest because there is also evasion techniques used by macOS malware and Linux malware. So as I said, at the moment, I'm probably the only one to maintain this project, and it's really hard to work on that on my side. At least for the whole time, I would like to work on it. But yeah, definitely the goal is to extend it to macOS and Linux as well. Great question.
Awesome. Thank you.
You got anyone else? No.
I do have a question for you guys. How many of you are already familiar with evasion techniques and malware analysis? Just raise your hand and I can see in the audience. 2, 3. Okay, only 3. So I guess you learned something today. So for the people that are working already in malware analysis and are familiar with evasion techniques, is it the kind of a project that is interesting for you?
Yeah,
Right.
definitely.
No, I think it's just.
Cool. Awesome. Thanks for the feedback.
Actually, I've seen malware even use Gmail drafts as a command and control mechanism. So it's definitely, yeah, I mean, it's good to have some sort of database, especially in my world with designing stuff, it does help. So really does open your eyes to, edge cases and usually it's those edge cases that get you. They never come through the front door. So
Right.
yeah, I think it's very useful. And, yeah, good on you for doing it, especially as a one-man band. Cheers.
Yeah. Cool. Yeah, and it's a very complex topic because the threat landscape is always evolving. So there is still new techniques that are coming, new process injection mechanisms. So of course the goal will be to have all the techniques in the database, but it's a lot of work.
Yeah, just put it into the thing.
Awesome, thanks.
Oh, I got a question. This
Yeah.
is not as good as the previous one. So, the previous comments. I was wondering if you could send us all the links that you mentioned on the presentation. I would like to put them in the YouTube below the YouTube video.
Yeah, sure.
So when people come to see the presentation, they can just, have access to these things if that's okay. Yeah, I think there's quite a lot of good links.
You
So
mean the links from the resources, right?
yeah, and
Okay.
yeah, yeah, yeah. Ah, there they are. Excellent. Thank you. I'll actually copy them before it disappears.
Actually,
Because
I have a question.
Yeah.
Some of the stuff you talked about, yes, the malware is obfuscated what it's going to do, but it eventually does boil down to CPU instructions or instructions in memory. Why doesn't it say CrowdStrike or say even Defender service or whatever? Why don't they pick this up at the end of the day? Eventually, something has to happen in the CPU and memory and the hard disk.
I'm sorry, I didn't hear the question well.
Eventually it boils down to something that AB can pick up because, eventually this stuff, even though it's obfuscated, will eventually will boil down to CPU instructions and something needs to be written to memory. So surely Defender or CrowdStrike will pick that up at some point, even though the delivery mechanism might get through, sandboxing and whatnot, but eventually at the end point it will get picked up by. Yeah.
So the question is, you said that most of the antivirus solution will detect the samples, will detect the techniques related to evasion techniques. Am I right?
Yeah, well, I'm talking about the actual PowerShell scripts and whatever's on there.
Yeah. So actually, there is plenty of techniques that can be used to bypass antiviruses on the machine. So that's why there is also like an antivirus evasion section in the project, where the goal is also to reference all the techniques used. But you are right, the goal is mainly to work more in the detection and improving the detection. And from me, for example, working in the Microsoft Defender team, the evasion techniques are really important because I'm also monitoring it, the detection, and see how we can improve the signatures and the detection within the Defender product. So you're right, there is a lot of mechanism already, but there is also new mechanisms used to bypass the security in place as well. I'm not sure if I answer your question.
No, it's okay. I the first time I said it, I got it out better than the second time. But yeah, no, it's okay.
All right.
Next time. Yeah. Oh yeah, no, cheers. It was good. Good presentation.
Thank you.
It's hard to repeat.
All right. Do you have any other question?
I think that's everything on our end. Rick, have you got anything?
No, I don't have anything on Discord yet. So guys, please feel free. There is a delay between when we say something here and in YouTube. It's like 10 to 20 seconds. So if anyone has further questions online, please put them on YouTube or Discord, and we'll ask them for you.
Yeah, definitely. If you have any question even after tonight, feel free to reach out on LinkedIn or Twitter, and I will be happy to answer your question.
Yeah, great. Well, let's put another 30 seconds. Thank you very much, Thomas. This presentation has been really enlightening, and yeah, I think that uh, this is a cat and mouse game, isn't it, between the antivirus and all the endpoint protection, all these things, and all the new evasion techniques that comes every day. It's like I was talking to somebody the other day, and they were talking about firewalls and whatever protection. I said, well, you spend all the money you want on a firewall, but then you find some teenager in the middle of somewhere finally finds a way across it anyway. Doesn't matter how much
Mm,
money you spend. So sometimes the human factor behind investigating those things is more important than actually the money you spend on these tools, to be honest. And I think this project of yours help the human component to learn how to detect these things, which is also very important,
mm,
besides the
yeah,
automatic tools, that
yeah,
sometimes they work, but most of the time they work, but when they don't work, that's where we come into place, and that's where we get paid good money, I guess.
yeah. That's right.
so, so yeah. Any other questions?
We're all good on our end, I think.
All right, great. I'm gonna. I got no questions. Any questions on YouTube, Cherry? Or
No, no questions here either.
all right, great. Thank you very well. No, thank you very much, Thomas. That was a great presentation. Thank you for everything.
Thank you. Thank you.
Hopefully,
Really enjoy.
great. Yeah, hopefully next time we will all be together down
Yeah.
in person. Yeah. All right, guys. I think we're gonna sign off. Thank you very much. You guys enjoy the food and everything that is there. Take lots of shirts and stuff. Eventually, we'll have some OWA stickers and shirts in there
Nice.
soon.
Perfect. Awesome. Thank you very much. Thank you very much for the welcoming, and see you soon.
Thanks, Thomas. All right.
Bye,
Bye,
guys.
guys. Thank you. Bye.